Okay, hi class. So we are moving on to 4.5. We're talking about logarithmic properties, and basically in this section we're going to be learning about the algebra and how to deal with using logs, log functions and things like that. And so we want to make sure we could do all that, and let's go ahead and get started. So there's some basic identities that we want to learn. And there's also some rules we want to learn, and we're going to use both of them to kind of get practice on them. So the first rule is that this says log base b of 1. Before I even get into these properties, remember what we did a couple sections ago about how to convert logs from exponents. So if you have y is equal to log base b of x, that's the same thing as saying b to the y is equal to x. So we're going to use that a lot today. So for instance, if this says log base b of 1, well, let's call that a number that we don't know. So log base b of 1 is some number that we don't know. We'll call it y. If you convert it to exponent form, this is going to be b to the y is equal to 1. Now b is any number that's bigger than 1, so let's just think about that as, like, for instance, like as an example, if I had 2 to the y is equal to 1. So really the unknown here is y. So if I have to ask myself, what exponent do I raise the number 2 to get the 1? Well, that has to be 0. 0 is special because if you put that as the exponent, it makes every number just equal 1. And so log base b of 1 then is just going to equal 0. And this is why when we were graphing logs, they always went through 1, 0. That was always the starting point. Okay. This one, next one, log base b of b, well, again, let me erase all this stuff here. Let's think about it in the same way. If we have log base b of b, let's just call that an unknown number. Log base b of b is some unknown number. And again, why don't we choose like actual values of b to make it a little simpler for you. So let's say like log base 5 of 5. Well, then that's going to say, okay, 5 to some unknown exponent has to equal 5. And it's pretty clear what this exponent has to be. That tells me y is equal to 1. So log base b of b is equal to 1. They just always cancel out. And this is FYI, why when we graphed a log, the key point was always b comma 1 up here. So the graph went like that. Okay, now this is pretty cool, this inverse identity. This says that log base b of b, and if you have it raised to a power, this x here, okay, comes to the front, and it just equals x times log base b of b. But what do we know what log base b of b is? It's just equal to 1. So a faster and quicker way to write this identity, I'll erase this to make it a little clearer, is that log base b of b just kind of cancels out and you're left with x. Okay, and last one, b to the log b. And again, this cancels out because guess what? Exponential functions and log functions are inverses. So b raised to something, that's an exponential function, but log base b is the log function, and logs and exponents are inverses, so logs and exponents cancel out. Again, because they're inverses. And so those cancel out and we're left with just x. Okay? So we're going to learn some more rules now, though. So those are just kind of the basics. Um, there are 4 rules we want to learn today. Sorry, 3 rules we want to learn today: product, quotient, and power. And the first one is called the product rule. I'm just going to write it out for you here. So this is going to equal log base b of m plus log base b of n. And this one is going to be log base b of m minus log base b of n. And the key thing here to remember is that the product goes with the addition, and the division goes with the subtraction. And why is that? Well, remember that logs are the inverses of exponentials. So if I have, say, a number, let's take like the number 10 as my base. So say b is 10, and I have 10 raised up to some number m, and I multiply it by 10 to the n. What's the rule for exponents? Well, if they have the same base, then what do? You add the exponents. Okay? This is the same rule but in log form over here. So this says if you have a log m plus a log n, then it's the same thing as the multiplying. And that's what we have here. So these rules just come from the exponent rule, that if I'm multiplying or a product, it becomes an addition like that. And it's the same thing with the quotient rule. So here, if I take a look at the quotient, if I have 10 to the m divided by 10 to the n, then that's going to become 10 to the, the rule is you take the top and you subtract the bottom. So it's m minus n. And that's why when you have a division, you have a subtraction, and that's why when you have a product, you have an addition. Okay? So let's get practice with that anyways. Let's start with this one with b. It's a little simpler first. Let's expand this log. So this expansion is going to be log base 8. Again, we have 2 numbers here. We have an 8 and a k. So when we have a product, it becomes addition. So it's going to become log 8 of 8 plus log 8 of k. And so that's the product rule. I'll write that over here. But we can go a little bit farther, because remember what we talked about up here, that if you have log base b of b, it just equals 1. So this is just going to equal 1. And so the final answer is 1 plus log base 8 of k. Okay, let's try this one. This one's a little more complicated, but because I have 3 things, I have 2 things going on. But again, this is like my first thing. This is like my second thing. It's definitely a product rule, so this is going to equal log base 3 of the first number, 30x, plus log base 3 of the second number, 3x plus 4. Like that. Now please notice that here I can't do anything. Okay? I don't have anything getting multiplied. These are getting added, and I can't do anything with the log that's getting added, but on the inside. But here I can do one more step. See how I have 2 things here? So I can split that up one more time, and that will become log base 3 of 30 plus log base 3 of x plus log base 3 of 3x plus 4. And I can't do anything else because I don't have any products anymore. Alright, let's take a look at this. These next few. So this is log base 2. So again, I have a quotient rule first. So I have top here and I have bottom here. So we'll do it first as a quotient rule. So it's log base 2 of the top, which is 15x x minus 1. Okay, it's going to be minus log base 2 of the bottom, 3x plus 4 times 2 minus x. I'll put that in a big bracket. Okay. But we can go farther. Okay, because now that I've done the quotient rule, I have the no more divisions anymore. I do have some products, so I have this times x, and I have this factor times this factor. So I can go one more step. I can solve all this, expand all this. So it's log base 2 of 15 plus log base 2 of x plus log base 2 of x minus 1. Okay, and I'm going to subtract the bottom ones, log base 2 of 3x plus 4 minus log base 2 of 2 minus x. And that gnarly thing is the whole answer there. Let's move on to this one. Hopefully this one's okay. This one over here was quite long. It was 5 things. The way I remember is that if there's anything on the top, that is going to stay positive. But if there's any terms on the bottom, then it's going to be negative. And so I had 2 terms on the bottom. So I should have 2 negative terms, negative this log and negative this log. Let's expand this one out, ln e over x minus 1. So I see it's a quotient rule first, so it's going to be ln e. Okay. And then that's the top, so it's positive. It's going to be negative, subtracting the one on the bottom, x minus 1. Now, is there anything else we can do here? You betcha. We can get rid of that because that's going to equal 1. Why is that? Well, what is ln? ln is log, it has base e. So this is exactly like this rule again, where we have log base b of b. It just cancels out to equal 1. And so this is just going to be 1 minus ln x minus 1. Just a quick refresher, a quick reminder. ln x, that stands for log base e of x. And that's called the natural log. And we also have one called the common log, which is log, just if it's not written, it's understood to be log base 10 of x. So this is called the natural log. This is called the common log. Okay. All right, so that's it for those rules. There is one more called the power rule, which says this. If you have log base b of m, this power here just comes to the front. And so this is equal to n times log base b of m. Okay. Why is this true? Well, let's take a specific example. So let's take like log base 5 or something. And say I have like, I don't know, say 7 cubed. Well, that's the same thing as saying log base 5 of 7 times 7 times 7. But what can we do here? This is definitely just a product rule, right? We have 3 terms right here. And so this I can split up to become log base 5 of 7 plus log base 5 of 7 plus log base 5 of 7. How many logs do I have now? Well, I have 1, 2, 3. I have the same amount as the exponent that I had. And so that's why this just becomes 3 times log base 5 of 7, which is exactly what the rule says. The rule says this 3 just comes down in front. And so that's why the rule works. It's pretty cool. So let's expand this one, log base 2 of x to the 5. Okay, so this is power rule. The 5 comes down to the front, and we're left with 5 times log base 2 of x. Okay, that's all the power rule says, really. It just says that the exponent comes down. I like to call logarithms anarchists because they take the power down. They fight the power. So let's go ahead and do this next one, ln of x squared. So again, this is going to be power rule. So the 2's here. It comes in front. And so we get 2 times ln x. Like that. Let's get more practice. Make sure we're doing okay. So let's rewrite this as a sum or difference. So we can't use all the log laws at once. So this, for instance, looks like a division first. So I'm going to do that first. So it's going to be ln x to the 4 y. That's a 4. Sorry. Okay, minus ln 7, because remember, quotient rule says the top is positive but the bottom is negative. And then I notice now I can do product rule because I have 2 things right there. So this is going to equal ln x to the 4th plus ln y, and I still have minus ln 7. But now with this ln of x to the 4th, this 4th power can come down. And so my final answer is going to be 4 ln x plus ln y minus ln 7. And you can always keep count because I had how many terms on the top? I had 2 terms on the top and I had 1 term on the bottom. So I should have 2 positive terms. I should have 1 negative term. Okay. So let's get practice again doing this one. So it looks like it's going to be quotient rule first. And I'm going to have 2 terms on top and 1 term on the bottom. And so I'm going to get log x squared plus log, that's actually a cube, sorry, it's hard to see on these notes. That's y cubed minus log z to the 4th. And hopefully everyone sees what we can do now. We can just do these exponents. And so we get 2 log x plus 3 log y minus 4 log z. Okay. All right. So that's kind of the basics. I do want to do a little bit more than just the basics here. Just to make sure we're remembering all the things that we can about exponent rules and stuff like that. So I want to just throw these at you. And if you take a look at the first one, A, it says, can we expand log of the root of x? And excuse me. Big sneeze. Okay, so yes, so the answer is yes, we can expand that log. The reason is that, remember what a root x looks like. Root x, another way we can write that is x to the half power. And that's really important, okay, really important to remember. Okay, I caught that sneeze off camera. Okay, so so when we have this, we can first rewrite it as log as x to the half power. and that means that the half power can come in front, and we're left with log x. Okay, so that's a key thing if you don't remember about rational exponents, is that a square root is like a half power. We can do it again over here. Here we have a cube root of x squared. Now that can be rewritten as x to the 2 over 3. The root always is the bottom of the fraction, and the exponent inside, it goes on top. And so we can rewrite this as ln x to the 2/3. And so that exponent comes in front, so it becomes 2/3 ln x. Okay. If you haven't seen these rational exponents before, that's kind of assumed knowledge about this material. So definitely see me. But in general, just to give you a pro tip, if you have a nth root of anything that's raised to the m, the way we write that is this thing goes, the m becomes the top of the fraction, and this thing becomes the bottom of the fraction. So it's x to the m over n. Okay, I want you to try this one. I want you to see if there's anything that you can do here. Go ahead and pause the video and take a look at it, and then we'll come back. And we're back. Nothing is the answer. There's absolutely nothing we can do to this log. This doesn't have a product or a division in it, so there's nothing we can do. We can't expand it. We can't do anything. So the answer is no. Can we expand it? No. We cannot expand it. I guess I should write no, not nothing, but we cannot expand that at all. Okay, so if you see addition or subtraction inside the log, that's a no-go. You can't do anything. Okay, so let's work backwards. Let's combine these logs. I'm going to move a little bit quicker here because this video is getting long. So if we want to write this as a single log, remember what the plus does. So this is going to be log base 3. The plus means you're going to multiply 5 times 8. And what does the minus do? It means you're going to divide by 2. And so you're going to get log base 3. 5 times 8 is 40 over 2, which is the same thing as log base 3 of 20. Okay, there I just used the quotient rule and the product rule, just going backwards. So this again tells me it's a product, and this tells me it's a quotient. The negatives and the pluses. Okay, same deal here. This is going to be a product. This is going to be division or quotient. And so we get, but before we could do that, I want to stress, before we do any of those, we first have to do the exponent rule. So please, please remember, always do exponent rule first. Always undo exponents first. So to do that, first step is that this is going to become log base log x cubed plus log x plus 5 to the 4th minus log, there's no exponent here. Alright, and then we can do the product rule and all that stuff backwards. This is going to become log the x cubed, and the x thing is going to become times. And this thing is going to become on the bottom, so it's 2x plus 3. And that's how that works. Okay, the last thing we want to cover is just how to use logs on our calculator. And if you go to your calculator here, we talked about a little bit a few videos ago. There are only 2 log buttons on our calculator. There's this log on the left side, okay, and that's called the common log. It's base 10. So if, for instance, if I plug in 10, it should equal 1. And there's also the ln, the natural log. So ln, and if I put in the e here, should equal 1. Okay, but there's other logs out there. There's log base 5, log base 2, log base whatever, log base 7. So how do we get those? Well, there are no buttons on our calculator for that. There's only 2 buttons for logs, common log and natural log. So how the heck are we going to get them? And the way you do it is actually pretty clever. It's called this change of base formula. So the way this works is that if you want any log, so b can be any number bigger than 1. If you want that log to enter in your calculator, we use this change of base formula. And the way it works is that you just do the common log divided by the other common log. So like that. So you take common log of m, whatever thing you were supposed to put in the first place. And so again, just to remind you, this is common log, so it's log base 10. I don't want to write that all the time, but just to help you, this is a log base 10. And you can do the same thing. You can do it with the natural log as well. The natural log will be natural log m divided by natural log b. So in other words, if I want to do anything here, I can just simply divide on my calculator using one of these 2, log or ln. It doesn't really matter which. Okay? So that's a formula that's important to remember, to memorize, okay, because that's how we apply any log that's not base 10 or base e. So for instance, if we want to use this one, again, there's no way we can evaluate that in a calculator without this change of base formula. So this is going to equal log base of the input, so not base, log of the input divided by log 5. Okay. If we go over here, we're just going to enter that now. It's going to be log 3. Oops, didn't work. Log 3 divided by log 5. And there you go. You get some decimal, nasty decimal, 0.6826. Okay. Just to help you identify, remember, this thing here is what goes on top. And this b is the base, so it's on bottom. So b is base, is bottom. Okay, let's do it again over here, log 2 of 10. This is going to be, again, this is what's going to go on top. So it's going to be log of 10, and the 2 is what's going to go on the bottom. So it's going to be log of 2. There's no algebra we can do here. Don't think that the 10 and the 2 talk to each other. Okay, the things inside of a log are like sacred. You can't mess with them. So here we'll just do log base 10 divided by log base 2. Oops. Do it again. Log base 10. Wow. It's pretty tough to do this with a pen. Log base 2 divided by log base, so 10 over 2. Okay. And that equals 3.3219. Now the cool thing is that this is going to be the same answer as doing ln. So if we do ln 10 divided by ln 2, we get the exact same answer. And so that's pretty cool. So that change of base formula works for either one. Okay. All right, so that's it. I'll post the rest of I'll post these notes on Canvas with the answers on the last page filled in for you to give you more practice. Okay, and see you next time.